Hello, I am Larry Walsh and I am an applications engineer at Yokogawa Corporation of America. Have you ever wanted to monitor your communications facility drift? That is drift of wavelength, amplitude, or signal-noise ratio? Well, now you can. What I am going to show you is a non-intrusive way of monitoring your network using an optical spectrum analyzer, OSA. You simply split a small portion of the light from your facility using a splitter and feed it to an OSA. Then program the OSA to monitor the facility and generate a log of its readings. For my demonstration, I will be using a Yokogawa AQ6370D OSA. You will see how easy it is to set up and make these measurements. The Yokogawa AQ6370D OSA has a new feature called data logging. This feature lets you set up an OSA to monitor and record the characteristics of your facility. In this example, I am going to keep things simple and use only one wavelength. First, sweep the trace you want to monitor. Then select the Advanced menu and select Data Logging and Setup. Within the data logging function, we have a number of different items such as wavelength, level, or signal-noise ratio that we can monitor. For this demonstration, I am going to select the graph item as level. I also select the graph channel as single, since we are looking at one channel only. The next thing to set up is the logging parameters. By selecting the type of signal we are going to log, which in this case is a WDM, in addition, I have to select the time interval as sweep time, so that I can automatically get the greatest number of data points. The test duration is selected in hours, minutes, and seconds. For this test, I will select 5 minutes. On this OSA, the peak detection allows for either absolute, relative, set level. I will select absolute and a level of 0 dBm. Lastly, I will turn on trace logging and opt to save the results to external USB thumb drive. This completes my setup. So let's start and execute the test. Since I chose a 5-minute runtime, the OSA will log data for 5 minutes and stop. I do have an attenuator in series with the input signal, so I can show what happens when the level varies. So let's give it time to complete the test. Now that the test is complete, you will see that during the test I attenuated the signal just to show what can be observed on the OSA. At the first occurrence, we can see where the signal has attenuated slightly. At the second, I have attenuated the signal below the selected threshold. Once the logging duration is complete, I can now save the data. We can give it a file name, for example ABCD, and select Done. That will save the file. You will see where I have selected not only to save the trace data, but also save the data to a CSV file. Execute saves the file and now save to a USB stick. You have now seen how easy it is to monitor and log your communications facility drift using an optical spectrum analyzer. Thank you so much for watching this demonstration today.